Okay, pre-algebra. So I do want to do a little brief review of lesson 4.2, which was Tuesday. One big takeaway from that is that all fractions can be expressed as a decimal. To do this, you just take the numerator divided by the denominator. So, for example, if we have the fraction 5 over 6, that would be 5 divided by 6. That gives you a decimal. If the decimal terminates, if it stops, then it's considered terminating. It ends. If it keeps going to the end of the calculator, it's considered repeating. And I have a little example here because it confuses students sometimes. Remember, the calculator, it has to end even on a repeating decimal. So you have to be careful. An example would be like the fraction 2 over 3, 2/3. That's 0.6 repeating. There should actually be a bar over that. The 6 keeps going. But the calculator, it goes to the very last digit and it rounds like we're supposed to do, right? It looked at that next digit, which was a 6, so it said to round up to a 7. So remember that the calculator just does that. It's just formatted to do that. But this fraction would actually continue to go on forever. Real quick, the answers to the exit ticket from a few days ago, 4.2. If you did not get that in yet, be sure to go back to Tuesday and do that so you can get those points. These were the answers. So on 2/3 and 4/7, it keeps going. We don't see the end of that, so those are repeating. So the two you should have selected were 1 over 2 and 19 over 20. Those were the two terminating decimals. All right, so we're going to go on now to 4.3, representing decimals as fractions. So we're kind of going the other direction this time. In problem 4.2, you found that you can represent every rational number in fraction form as a terminating or repeating decimal. In this problem, you will investigate how you will reverse and represent decimals as fractions. Can you represent every repeating or terminating decimal as a fraction? That's what we're going to find out today. So the first one that examples we're going to look at are a few of these here. So we're going to learn how to kind of predict how to convert these. So take a moment, look at these two problems, and 1/4, and then we have below it 1/8. Think about what you can do, what you know about these, that might help you figure out what the solution would be. How you can figure out 1/8 without a calculator just by what we're given so far. So, I know this writing is kind of small here. Let me go back to the larger version. What we can do here is that I know that 1/8 is half of 1/4. It got smaller by a half. So I can also take this answer and divide it by 2. And a lot of people a little hesitant with decimals, but if you look at this number 0.25 and you think about it just like the number 25, all I did was move that decimal over 2 places. Well, 25 divided by 2, I know is 12.5. So now all I need to do is move the decimal back, and I know that this must be 0.125. And I just divided the decimal by 2 because I knew that this was 1/2 the size. So very similar on the second one, 1/3. Well, 1/9 is like a third of that. It got smaller by a third, so it's like dividing by 3 instead. So here, I know that 3 divided by 3 is 1, and it would still have the bar over it, 1 repeating, going on forever. So just showing you some patterns here, making some of this a little easier. seeing that if it starts out as a repeating decimal, like over here, it stayed a repeating decimal when we took 1/3 of it. And I want to show you now a pattern, and I asked you about this on the last ed puzzle that you had on fractions. We're going to extend this pattern that we found in the nights and continue that. So, looking right down here in this section, and I'll show it again on a table in just a moment, hopefully the other day you noticed that with nights, whatever is repeating, that is the numerator over 9. So we can kind of convert back and forth on those types of problems. So let me show now on this larger version, looking just at the nights section. Here, we can see on each of these, I just went through 1/9, 1 divided by 9 in the calculator, and I get 0.111111. And I do 2 divided by 9 in the calculator, I get 2.22222, 0.3333, and we can see this pattern. And it would continue. So if I get down here to 8/9, I get 0.8 repeating. So that pattern continues. So that's going to be useful to us on a few practice problems. So looking here, we have the problem 1.2 repeating. So the first thing I'm going to do is, I know that when I convert this to a fraction, I'm going to have the whole number 1 out in front, 1.222, right? So the whole number there is 1. Now the decimal, I can look back at this table over here and see right here that 0.2 repeating is 2 nights. So I know this must be 1 and 2 nights because I know that pattern. So take a second, look at number 2, and figure out which one of these would be the correct answer. All right, hopefully you saw, again, the whole number 2, it's the number 7 that's repeating, so we end up with 2 and 7 nights. So number 3 is a different type of pattern. We're gonna, we'll talk about that one in a little bit here. But on number 4, I want you to notice, because at first it looks like that 27 is repeating. But if you look closer, we have 2, 7, and then 2, 7, 7, and then 2, 7, 7, 7. So it's very easy to get confused by the terminology. This pattern goes on forever, but it doesn't repeat. The pattern is changing. So this is the one type of problem or decimal that we cannot turn into a fraction because the pattern doesn't change, or the pattern keeps changing. We can only convert decimals that either repeat or terminate. This one doesn't repeat and it doesn't terminate, so we, on number 4, cannot convert. And we'll talk more about that type of number in our next lesson, but that is a special type of decimal that cannot be turned into a fraction. There is no fraction that represents this decimal. All right, so let's go ahead, look at a few more problems. So what's neat about this pattern with the 9s is that it works for other numbers that repeat. So I see here that the number 15 is what's repeating. So if we think about this pattern that we were working with, remember I had up to 8/9, and it was 0.8 repeating. Well, if we have 2 numbers that repeat, 1, 5, I need 2 digits down below. So the pattern goes on. So for this one here, I would have the number 15 over 99. Now that can actually be simplified. Both of those are divisible by 3, but that gives us the first number. All right, now I'm actually going to skip down to C. It's a little tougher, and then I'm going to have you try out B on your own. So again, looking here, 3, 5, 4 is what's repeating. This one has that whole number 1 out front, so I know I still need the whole number 1 out front in my fraction answer also. And again, the pattern, just like above, continues. If I have one number that repeats, I have it over 1 9. If I have 2 numbers that repeat, it's over 2 9s. And if I have 3 numbers that repeat, then it's over 3 9s. So this would be 1 and 354 over 999. So now try B on your own, and I'll put up the answer in just a moment. All right, we have 3 digits that are repeating, so it needs to be over 3 9s. Now, just for your own practice here, if I had the number, say, 0 1 5, 0 1 5, that's repeating. That even though there's a 0 there, there's 3 digits that repeat, so it still has to be over 3 9s. Types like that sometimes throw people off a little bit, but it's based on how many numbers are repeating, even if one of those is a 0. All right. And real quick here, we're going to look at this true or false statements. Here, you can write any fraction as a terminating or repeating decimal. This is true. We just have to take numerator divided by denominator. Next part, you can write any terminating or repeating decimal as a fraction. This is also true. If we can convert it one direction, we can always convert it back to the other format. All right, just a few more little examples here, showing you some of those practice, those patterns here. So if you notice here, this went and became 10 times smaller. So what we can do is just move the decimal place, because that's a power of 10, by 1 place. And we get 0.025. Same idea here. This went decreased by 100 times. So this 0.3, we would move the decimal 2 places, and we get 0.003 instead. So I just wanted to take a moment and show you another one of those patterns. And if you have any additional questions, please send me a message, and be sure to answer the practice problems below, or the practice problems on your exit ticket.